Well, I'm learning a lot today. This is great. I'm Tim O'Connell. I'm a longtime researcher into this issue, and I'm really excited about this particular session four, which is looking at databases, both evidently sort of what we can learn from it and best practices to make sure we can learn from it everything we want to be able to. So we begin with Simon Tai from the University of Arkansas, who has longstanding experience in mass die-offs, and he's going to talk to us about bird declines and how they might relate to bird collisions. Simon, go ahead, please.
Thank you, Tim. I'm going to share my screen really quick. Quick transition. Okay, welcome everyone. My name is Simon Tai, and today I will be discussing why North American birds are declining. The picture shown here is from Flap Canada and shows dead birds that were collected on surveys. As many of you know, the abundance of North American birds has declined by about 3 billion individuals from 1970 to 2016. More recent papers suggest this decline is ongoing. This figure from Rosenberg et al., 2019, shows the total abundance decline on the left, abundance change by breeding biome in the middle, and proportional change by biome on the right. Grassland, boreal forest, and western forest birds have been the most affected, and only wetland birds have increased in abundance. Overall, most species in nearly every biome have declined. Notably, this is a global conservation issue and not a national issue. A few weeks ago, it was reported that 61% of all bird species globally are declining. Despite numerous programs for surveying live and dead birds, current conservation approaches do not explicitly link species abundance and species fatalities through time. It is my hope that linking abundance and fatalities could enable real-time species monitoring, likely at an annual scale to align with current live bird surveying programs such as the Breeding Bird Survey, Christmas Bird Count, and similar programs. To this end, I compiled the largest database of North American bird deaths by synthesizing 7 databases maintained by government employees, academic researchers, conservationists, and community scientists. This synthesis contains deaths recorded by USGS, U.S. Fish and Wildlife Service, New York City Bird Alliance, Flap Canada, iNaturalist, and several peer-reviewed publications. In total, it includes over 8 million fatalities across over 800 species over the last century. Oh, I wanted to say one more thing. To compile this synthesis, I personally contacted all of these organizations and more, which did not have fatality data, obtained a FOIA request, and wrote over 35,000 lines of code, which will be publicly available soon. Using this fatality synthesis and abundance data from the 3 billion birds paper shown earlier, I will address 4 important questions. First, why are birds declining? From a demographic perspective, this decline could be attributed to changes in birth, immigration, death, or emigration rates. Immigration refers to individuals that enter a population, and emigration refers to individuals that leave a population. Second, why are birds dying? Knowing this could strengthen targeted mortality mitigation strategies. Third, where are deaths documented? Knowing this could help establish regionally specific strategies. And fourth, it is important to understand where deaths are under or overrepresented of specific species and specific regions to improve data collection. Shown here are the temporal and spatial extents of the fatality synthesis. On the left is the annual number of fatalities over the study period from 1970 to 2016, with each color representing a different database. COSPEC and Fay et al. 2015 are academic reviews of vertebrate fatalities and mass die-offs, respectively. DBird, FLAP, and iNaturalist are community scientist databases, and U.S. Fish and Wildlife Service and USGS are government databases. Notably, most fatalities were documented by government employees, though a growing number have been recorded by academics and community scientists. On the right is the spatial extent of the study range, which spanned from Panama northward to Canada. Most fatalities were recorded in the eastern half of the United States, which was expected given the high human population density. I first use these data to understand whether elevated species mortality rates have contributed to the decline of birds. To do so, I combine the fatality synthesis with species abundance data from the 3 billion birds paper. I then separated the fatality and abundance data into 4 partitions based on each species' total abundance trend and their annual abundance trend. In this study, I defined species that have decreased or increased in total abundance as declining or gaining species, as shown here by a western meadowlark and American white pelican, respectively. I then separated data by annual abundance trend so I could specifically focus my analyses on years in which species abundances either decreased or increased, shown here as decreasing or increasing years. This partitioning approach allowed me to ask a simple question. Were more dead birds documented when fewer birds were observed in standardized surveys across hundreds of species at an annual scale and across the entire continent? Such a pattern would provide strong observational evidence that elevated mortality rates have contributed to the collapse of birds. These figures show that very pattern. On the left is declining species in decreasing years, and on the right is declining species in increasing years. The y-axis shows the annual number of fatalities for a specific species, and the x-axis shows the annual extent of abundance loss or gain for a specific species, all of which corresponds to the same year. For example, 1 point could represent 1,000 dead western meadowlarks in 1990 and 10,000 fewer western meadowlarks in 1990 compared to 1989. The positive slope on the left shows that there were more documented fatalities when large abundance losses were observed. The weaker but also positive slope on the right shows that there were also more documented fatalities when large abundance gains were observed, which may indicate that high mortality rates are hindering the recovery of declining bird species. These models accommodated for expected data distributions from count data and accounted for important covariates, including standing abundance, year, and genus. In other words, these models accounted for the fact that there would be more fatalities of abundant species, there would be annual variation, and species with a shared evolutionary history would exhibit similar patterns. Shown here are the same models, but for gaining species. The lack of slopes in these models showed that fatalities were not elevated alongside large abundance losses or abundance gains for these species. Collectively, these models show that there were only elevated fatalities for declining species, and especially so when large abundance losses occurred. This is the strongest observational evidence to date that birds are disappearing because they are dying. We performed additional analyses to corroborate this claim via the inverse relationship, or whether fatalities predicted abundance change rather than whether abundance change predicted fatalities. I will not discuss those results today for time's sake, but they showed the same pattern. Importantly, the decline of birds may also be affected by change in birth rates, but information about those changes is limited. We therefore evaluated whether key traits related to fecundity or birth rates varied with different extents of fatalities and abundance change. We specifically focused on the size of clutches or the number of eggs that are laid, and the number of clutches or the number of times eggs are laid. First, there was no effect of size of clutches or number of clutches, and therefore changes in birth rates likely had a negligible effect on our findings. Additionally, we expected observation bias towards species with large body sizes and range sizes because they are easier to observe than small-bodied, narrow-range species. Sorry, excuse me. As you can see here, there was an effect of body size in that there were more documented fatalities of large-bodied bird species, yet small-bodied bird species are disappearing faster. We therefore performed a third set of analyses for our main question about elevated mortality rates, which also considered the effect of body size. These models once again showed the same pattern. The declining species have died at an alarming rate, and especially so in decreasing years. Next, I evaluated trends in extensive fatalities attributed to different causes through time. Across both declining and gaining species, there were more fatalities attributed to infectious disease, anthropogenic or human-based factors, and multiple stressors, or a combination of multiple main cause types shown here. For only declining species, there were also more fatalities attributed to predation and fewer fatalities attributed to biotoxicity, or toxic biological organisms such as cyanobacteria. Notably, predation observations rarely identify the predator, and despite free-roaming cats killing billions of birds, we could not include predation as an anthropogenic source. I then evaluated trends in fatalities through time attributed to different infectious agents and anthropogenic factors. Shown here are different infectious agents. Across both declining and gaining species, there were more fatalities attributed to bacteria and flatworms through time, but no such trends for protozoans, viruses, and fungi. Among anthropogenic factors, there were more fatalities attributed to collisions for both declining and gaining species. Additionally, there were nonlinear trends in fatalities attributed to biocides, or synthetic chemicals designed to kill life, and pollution, or coarsely described chemicals or pollutants. While seemingly reassuring, it is important to note that these patterns are affected by recent abundance changes, such as the loss of half of all grassland birds, which are particularly susceptible to biocides and various pollutants. Next, I wanted to understand where these deaths were documented. According to the 3 Billion Birds paper, the largest recent declines have likely occurred in the eastern half of the continental United States, as shown here in red. Our data corroborates this pattern. These figures show the total spatial extent of fatalities attributed to each of the main cause types shown earlier. Fatalities attributed to anthropogenic factors, infectious disease, multiple stressors, and starvation or dehydration were concentrated in the eastern United States. By comparison, most biotoxicity-related deaths were concentrated in the southeastern U.S., where many organisms that contain biotoxins occur, whereas predation-related fatalities occurred across the entire country. Oops, and last one. Weather-related fatalities, forgot that one. Were concentrated in the Great Plains region and along some coastlines, which are regions that have experienced sharp increases in extreme weather events due to climate change. Finally, I wanted to understand whether fatalities were over or underrepresentative of abundance change in specific breeding biomes to improve future data collection. Here, larger negative values indicate greater underrepresentation, and larger positive values indicate greater overrepresentation. Notably, all values shown here are negative, and therefore fatalities were underrepresented across all biomes, indicating that more deaths need to be recorded across North America. In particular, more deaths need to be recorded in arid land, coastal, and western forest biomes, most of which occur in the western United States. This study has several implications. First, it reframes the collapse of North American birds from a crisis of declining numbers to a crisis of survival, which will ideally increase funding and resources towards mitigating bird deaths. Second, because this study shows that fatality and abundance databases align, integrating surveys for live and dead birds could enable real-time species monitoring. More simply, if we find many dead birds of a particular species and run similar statistical models as in this study, it could indicate why species are declining in a specific region. Third, understanding causes of fatalities in specific regions can help strengthen targeted mitigation strategies that will benefit local populations. Fourth, this project showcases the combined effort of all scientists, from government employees to conservationists to academics to community scientists. Together, I believe we can slow the collapse of birds. Fifth, this project highlights the immense value of documenting dead birds and will thereby encourage better data collection. And I will close out this presentation by discussing how we can improve data collection very briefly. Caitlin will be talking a bit about this in the following presentation. But just with my experience with this project, I'd like to highlight some things. First, it is important to include the date, time, and coordinates of all observations. Most databases request this information, but not all observations contain such information, and therefore it is worth reiterating. Second, observations should include both a primary and secondary cause of fatality. For example, knowing that a bird died from a collision and specifically because of a window would be beneficial, as would knowing the predator species that killed a given bird if possible. For this study, I had to combine all forms of collisions, from buildings to turbines, and all forms of predation because of data deficiencies. Third, databases should consider using a specific taxonomic system. Many bird names were misspelled, and different databases use different taxonomic systems. Fourth, most databases do not include survey effort, such as the time spent surveying or the distance traveled on a survey. Without survey effort, our current fatality estimates are at best a minimum estimate. Including survey effort will allow for higher quality predictions, as well as allow for extrapolations that reveal larger and more accurate estimates. Fifth, our analyses show that small-bodied birds and birds of the Western United States are severely underrepresented, and therefore greater effort towards documenting those species and in that region is necessary. While not discussed here, we also now have information about leading causes of death for each species, though they are somewhat biased by underlying databases.